So, getting to problems involving rational expressions. Rational expression problems often involve rates. Okay, so we're talking about some sort of rate problem. So we have Jason and Craig, they're neighbors, and they want to fill Craig's pool with water. So they have both have a hose, and they're going to fill the pool with water. Now, the rate that Jason's hose can fill the pool is it can fill one pool in 6 hours. And again, although it doesn't seem like it, this is a rate, one pool, 6 hours. Craig can fill one pool in 3 hours. So how long does it take for them to do this together? Well, if I were to think, okay, well, I want time, so I'm just going to add the time together. It doesn't make sense that if one person could do it in 6 hours, another person can do it in 3 hours, that it's done in 9 hours together. Okay, it should be shorter time. So we can't add time together, but what we can add is a rate. And from the rate, we can figure out the time. So I've made a little chart here. Okay, so we have our little chart. We have Jason's time, Craig's time, okay, and we can show it this way. So let's do it here with an example where it would be quite easy. So if one person can fill it in 5 hours, another person can fill an exact same amount, so they're both working at the same rate, it should take half the time to fill the pool. It should only take 2.5 hours. And it would look like this. So I'm just going to do this in red. It will fill one pool in 5 hours. That's my rate. And I have one pool in 5 hours for Craig. That's our rate. If I add them together, I get two pools in the same 5 hours. That would make sense, because if they each did their own pool, they'd be done in 5 hours. And if I want to know the number of pools in 1 hour, I can just flip that. I have 5 hours for two pools. That means each does it, together they do 2.5 hours for the one pool that they're going to fill. Okay, so this is how our algebra works for this as well. We can't add time, but we can add the rates. Okay, so we could do the same thing here. Let's say that Jason does one pool in 10 hours and Craig is one pool in 2 hours. We should be able to do together, although Jason's not going to do as much work as Craig, it should be less than 2 hours. So when we add these together, we need a common denominator. So we're going to end up with 5 over 10. And so we get 6 over 10. So what that means is, in 10 hours, this guy will get 5 pools done. This guy will get 1 pool done. So we get 6 pools done in 10 hours. Okay, so 6 pools filled in 10 hours. So if I want to know the hour for one pool for them to work together, so this is now working together, we can add those rates. We have 10 hours for 6 pools. Okay, so that's about 1.6 repeating hours per pool. Okay, and we can do another example here. We have one pool in 3 hours, one pool in 1 hour. Okay, we can add those together. 1 over 3 plus 3 over 3 gives us 4 over 3. So we get 4 pools in 3 hours done. So we get 3 hours for 4 pools, which is 45 minutes or 0.75 hours. 0.75 hours per pool. Okay? So we can see that this case here, or the problem that we had, and we'll solve it this way. Okay, so we're going to do our rate. So rate of Jason is equal 1 pool in 6 hours. Rate of Craig is 1 pool in 3 hours. Okay, rate together is equal to 1 over 6 plus 1 over 3. Okay, and that gives us, well, this is going to be 1 over 6 plus 2 over 6, which is 3 over 6. Okay, so in 6 hours, they would get 3 pools done. So Jason would get 1 done, and Craig would get 2 pools done. So together they would complete 3 pools. Okay, so 3 pools in 6 hours. That means together they do 2 hours for 1 pool. Okay, so we just flip that ratio around. The last part of this is, and now this is a little bit more advanced, but essentially we could do this with variables too. We could say that Jason does 1 pool in X hours, and it looks like Jason can do it 3 hours quicker, so Jason's going to be, or Craig in this case, Craig can do 1 pool in X minus 3 hours. We add those together, 1 over X plus 1 over X minus 3. Okay, doing the algebra, we're going to end up with X minus 3 plus X over the common denominator of X times X minus 3. Okay, I'm just going to use one more line here, so we end up with 2X minus 3 over X minus 3. This is the number of pools. This is the hours. So if we want to do this as a rate of hours per pool, we just say, flip that around. This many hours, this many pools. Okay, so we can do this algebraically as well. Now this is a little bit more advanced, but essentially we're using the exact same process, but now with variables.